Where's Clancy?
I don't know. Should be.
He was talking to me this morning.
Yeah, I think it'll be here.
He set a new deadlift personal best yesterday.
Mm-hmm.
In terms of like percentage of body weight, I wonder how much your legs weigh.
Probably a fair bit.
You think?
Yeah. It'll be a bit.
Because I feel like my upper body's way heavier than my lower body on my body. Because I've been doing squats but without extra weight.
Mm-hmm.
And I'm trying to figure out how much am I squatting. Am I squatting like 275 pounds?
I don't know. I don't know how you calculate it.
I have to figure out how to weigh your legs.
Yeah.
No medical expert, but I think.
I would have made that guess to begin with. It's like, look, I'm not a doctor.
That's my point. It's like I need to clarify. I'm trying to think in my head.
All right. So let's start looking. So homework today was what? addEnd, removeEnd, getEnd? Those three? How'd that go?
Good.
Yeah?
I just got it working now.
Class started 5 minutes ago. Did you turn in?
Yeah.
Are you lying?
Well, I turned it in, but it didn't work.
Oh, so you turned in crap and now you have it working.
Yeah.
Did you update your GitHub?
Not yet.
Update your GitHub. Yeah.
How are we supposed to test, like, when they return a value, if it's not printing a value?
Well, you can print it out.
Oh,
You could.
okay.
You get the value and then you print it out. We'll do it today.
Okay.
We'll do it today. Oh, it looks like there's a new version of Visual Studio Code.
That's what that update thing is.
Yeah, I ran an update this morning. Ubuntu keeps track of what you have installed, and it will update those software packages. Well, I mean, I wouldn't maybe right now in the middle of class if you want to play along, but Clancy, I was letting them know about your new deadlift personal best. What was it?
30.
530?
Yeah.
And then we were trying to figure out how does one weigh their own legs?
That's a good question.
Because I'm trying to figure out what I'm currently squatting, doing a squat with no weight.
They have machines that like you can go in called like bod pods. And that,
Called
like,
bod pods?
Yeah.
Yes.
That sounds like a type of fancy machine that I might not fit in. Like a lot of the equipment at the gym, I don't fit in the equipment. Like I don't get in the thing. It's like too small.
You just cut your legs off.
Well, no, my legs are little compared to the rest of my body.
Then you can measure.
That thing.
then you can weigh your legs. You cut your legs off, you throw it on the scale, you look at the number. That's how much your legs weigh.
Hey, you just gotta, fiddle around.
There probably is something you could do across like a couple of scales. Because I used to, before I got a scale at home that could weigh me, I used to have two scales that you just load balance across the two of them, and you add the two numbers together. True story. You can't use a digital scale for that. You gotta have to use the mechanical ones, and then get once the numbers stabilize-ish, you can add them together. But now my scale, I was showing errors again.
Segmentation.
Yeah, I think it's like a weird max weight because it's like I think it's supposed to go up to 430, but I'm thinking I'm 403. And so it'll weigh me at 402.8, but not at 403. Or maybe it's just like giving up. like whoa. Hold on there. All right. So there's our node stuff. Get rid of our dice stuff. All right, so we are writing addEnd, getEnd, removeEnd. So let's look at our picture for writing addEnd first. All right, so if I happen to have a list that looks like, if I have the empty list, so let's write that part first. So we'll go ahead and write addEnd. All right, so if I have the empty list, what do we actually want to do? If I have the empty list, can't I just call add front? I can call this guy's add front. If my list currently has nothing in it, is an addEnd and add front the same thing? All right, so I can say either if count is equal to 0 or if not. This dot head. So if not this dot head, I can say this dot add front payload. Does that make sense? So if my list currently has nothing in it, rather than doing anything special here, I've already written code that will add something to a list that has nothing in it. So I'll just call add front, passing it that payload on. Yeah.
So for it to be a list, we wanted to have at least 2 values, so we wouldn't just make one value both head and tail.
Well, we're currently not going to keep track of tail. We're going to be keeping track of tail, but right now the only access point to our list is through head. Basically, if we have the empty list, adding to the end or adding to the front are synonyms, right?
Oh. Okay.
So that's what we're saying here, is if head currently points to nothing, go ahead and call your code that already adds to the front. We could write it again here and duplicate that code. That's not going to kill anything, but we already wrote it. So we'll just call add front to add to the empty list. Otherwise, if I'm here, we have at least one thing in our list. So what do we need to do? We need to get to the end of the list to hook up our new thing, right? So traverse to end of list and connect new node. So the first thing we'll do is we'll actually create our new node. So we're going to create a node pointer. We'll call it n. And this guy is going to equal a new node out of our payload. So now I have a new node that I'm going to put somewhere. So what I just did here is we'll give ourselves the one list. I just created this guy. So we'll have a count of 1 there. We'll disconnect this extra variable. And currently what I just did is I created this guy. And head points there. So my list looks like at least a 1 list like that. Possibly a 2, 3, 20 list, right? And then I went ahead and I created a brand new node here. So that's what this line of code does. Make a new node. Now I need to traverse from the beginning of my list all the way to the end of my list. Make sense? And how do I know I'm at the end of the list? What tests can I use? Again, human beings, we remember stuff, we ask questions, we use repetition. What question can I ask that will return true when I'm at the end of the list? Go ahead.
If next node is null.
Yep. Okay. So we're going to do this instead of using count, which, he asked the question last class, can we use count to do this? We can. Okay, but we want to really focus on using memory right now. It's not wrong to use count. I'm just going to, whenever possible, choose to use memory as my test case. All right. So I'm going to keep track of a node called cur node. And I'm going to start this guy off equal to head. All right, so I'm going to point to the same place head points to. What does that do? That gives me, here, I'll just rename this guy cur node. So I just created a variable that is equal to the same thing that head is equal to. Make sense? So I have 2 different variables both pointing to that first guy. Why do I need a second variable pointing to that first guy? Go ahead. Yeah, so I never want to lose track of the head of my list, right? So I'm not going to be updating this value unless I'm adding something to the front of my list. So I need to have another guy that starts off as being the same thing as head, but I can move this guy and not break the value of head. Make sense? So I have two pointers that start off pointing to the same place. And now I want to keep updating kerNode until kerNode's next node is equal to null. So while not kerNode get next node. So this guy returns true when kerNode has a next node. I'm sorry. While kerNode.get next node returns true when kerNode has a next node. So this asks the question, if kerNode's next node is something, not would be if kerNode's next node is nothing. That's our stop case. So as long as kerNode's next node is something, we want to set kerNode equal to his own next node. Walk kerNode down our list. So as long as kerNode, this guy, has a next node, so if I just, as an example, have this guy point here for a moment. So as long as kerNode's next node points to a real thing, I'll make kerNode equal to his own next node. Make sense? So run them down the list until I finally get to a point where kerNode's next node points nowhere. All right, so once I get to this line right here, kerNode now points to the end of our list, i.e. the last node. All right, that makes sense? So just so I don't have to create another node here, kerNode now is at the end of our list. So our picture looks like this right now. So it doesn't matter whether this was the first node or the 3000th node. kerNode is now pointing at the end of our list. And then what do? I set kerNode's next node equal to n. kerNode set next node to n. Make sense? So kerNode is this guy right here. Set next node equal to n. That's what I just did. Make sure you're drawing pictures when you're working on your homework. If you're not drawing pictures, you're going to struggle. Struggle. How many of you are not drawing pictures and struggled? Several of you. Draw pictures. Especially for this next thing we're going to do, we're going to be putting values in the middle of the list. Okay, that's a little bit more complicated surgery. This is outpatient stuff. Okay, you can go into urgent care and they'll just do this as while you wait. Okay, but once you go and start adding or removing stuff from the middle of your list somewhere, and you got to start hooking up pointers and not lose stuff, you're going to want pictures. All right, go ahead.
I think this code wouldn't necessarily be very efficient for long lists.
Well, I mean, it'll be as efficient as a linked list can be. Remember when we talk about arrays versus linked lists, the trade-off is speed. Arrays are very fast, but they're memory inefficient. Linked lists are relatively slow, but they're memory efficient because we're only creating buckets in memory whenever we need a new node. And it doesn't necessarily have to be contiguous. So the fact that we're not operating in a contiguous memory means that we always have to start at, for us right now, the beginning of our list and get to where we want to go. Eventually, we'll keep track of the beginning and end of our list, and then we can make a decision on where does it make more sense to start from. All right, that makes sense? So I would say don't get too caught up on the efficiency of this because the efficiency we're trying to gain is memory efficiency. And since we don't necessarily care about speed today because our processors are so quick, and maybe we even don't even care about memory that much, just having the ability of creating a collection of arbitrary size, where it can start off with nothing in it and go to 5, then go back down to 3, and then go to 26. Having something that is very flexible and can change in size without us wasting a whole lot of internal space or keeping track of where the real end of the array is beneficial just from a problem-solving perspective. Yeah.
As a general rule, do programs like video games and operating systems stay away from linked lists then?
Not necessarily. Depends which aspect of the game you're dealing with. If it's something that's a performance portion of the game, let's say maybe. But if it's something that your inventory or something like that, they might choose to use arrays. Like World of Warcraft, for instance, you have a bag size, and that's the number of slots in your bag. Maybe they choose an array because you have a maximum number of elements you can hold in there. But if you get some games will have like a bottomless bag type thing, where you don't know how many things you're going to have, then you.
The array can just simply keep track of everything.
Yeah. So the answer is not necessarily, but anything that's going to directly lead to performance, they would probably choose arrays over, and then just up the minimum memory requirement for the
Call
game.
of Duty for like a magazine count, you would probably use an array because.
Probably because that's something that's manipulating in real time. Yeah. But keep in mind that even with that, if you have a magazine count that starts at 20, as it's counting down, you have to keep track of where is the last, current bullet, right? So you are now taking up a little extra memory, remembering where the actual end of your array is. Because you actually have an array that has legal buckets 0 to 19, but you only have values in buckets 0 through 9 or something, right? So it's not quite as cut and dry as, which is why when we first introduced arrays versus linked lists, don't look at linked lists as an upgrade or a downgrade to arrays. They're another tool that we can use when it makes sense.
So what I'm confused about is, so you have all these nodes, right?
Mm-hmm.
And then you're making a copy of head and then traversing, right? Essentially making a copy of each node.
No, you're not making a copy of each node. Head is a variable that just holds a memory address. That's all head holds, is the memory address where this guy lives, not the node itself. Head is a pointer. So we are making a copy of the memory address that head points to. And then walking this guy through. So this is got a 32-bit operating system. This is 4 bytes that we have made a copy of. Not a whole node.
So when you set cur node, set next node, you're actually setting the next node of the actual node, not a copy of the node.
Well, it's the address of the next node. If we look at node, a set next node, let's look at node HPP. Next node is a variable capable of holding the address of a node. So it's not the node itself, it's where that node is in memory. Okay, so none of these are we actually setting, we're not making duplicates of the house. We're just having one other guy point at the house. Say, I'm going to remember where that guy is because I'm about to leave this place. Go ahead.
So we're looking at pointers as separate entities, right? We can have a pointer without a node, but we can't have a node without a pointer.
If we have a node pointer, are we specifically talking about node pointers?
Well, can we have a pointer without a node? Like just
Well, I mean, yeah, right now, this guy is a node pointer, and we don't have to have a node exist. He can't point anywhere, but he is a variable that is capable of holding the address of a node pointer. We just don't have an address to put in there. So he can exist, but we can't follow it. Yeah, in order for a memory address of a node to exist, a node must exist. Yeah, I can't give you the address of my house if there isn't a house there.
So the pointer that points to head, like we can't access that, but it's on its own without a node. It's just pointing to head, right?
Say that one more time.
So like in your picture, you just show the pointer, like right there, the LL.
Yep.
That's just a pointer that's pointing to the first node. Because it's not connected to a node, we can't access that pointer.
Correct. So head holds the value like 200, which happens to be the memory address where this node lives. He doesn't hold the node, he points to the node. Go ahead.
One question I have is a little off topic, but so like let's say we were to make a new class, entirely new project, and we wanted to import this project so we could have access to our linked list.
Mhm.
Is there a way that just by importing the linked list, it also imports the node without having to directly import the node?
Yeah, you should be able to just include
Or
linklist.hpp.
And that will include the node?
Yep.
Okay, I was just curious. Okay,
Yeah, as long as linklist.hpp included the node.
okay, that
Yeah.
makes sense.
Go ahead.
So if you have access to a node via a pointer, you can call that node's methods.
Yeah, and that's what we did right here. I'm calling curnode, which is a pointer. I'm calling that node's methods. But remember, this guy is syntactic sugar for star curnode dot get next node. So star curnode says boil down to the actual node at that memory address. Give me the value at the memory address that curnode points to. All right, so this syntax right here says resolve this guy to the node, then call that node's next node method. That make sense? All right. So where was I? So in addEnd, we create our node, start off the beginning of the list, run ourselves to the end of the list, make the end of the list point to our brand new node, and then increment count. One more thing in there, right? All right, so we should be able to test this. Oh, did I delete my main? Or I just closed it. Go ahead.
You have to delete
Never mind.
the
I
kernel pointer.
The who, what?
You have to delete the kernel pointer after that.
No, because it's a local variable of this. We don't want to get rid of this memory associated with n, for example. Curnode is a local variable just like int a equals 5. We wouldn't delete the memory for that because it still points to a real place. So deleting memory doesn't say delete this variable. It says release that memory to the operating system so they can hand it out to somebody else. We don't want him handing out n, whatever node we just created, to somebody else. We don't want him handing out the end of our list that curnode currently points to somebody else because it's still part of our list. Curnode just pointed to it for a minute. So it's a local variable that will go away at the end of this. Its scope lives and dies with this method. Yeah.
Why wouldn't we make something like kernode a global variable? Like, why do we have to initialize it in every single?
Well, because I mean, in general, global variables are bad ideas, and kernode's going to mean different things in different methods. So, I mean, you want to keep your code as organized as possible, not just have a collection of random variables sitting out there somewhere that you can use from anywhere when you can just quickly create a new one. It's not like a heavy variable. Okay. So either just add it to the front or traverse the end of the list, add it to the end of the list, increment our count. Let's test this. So I'll go ahead and here I'll comment that out. So we will go ahead and do an LL addEnd 3, and then we'll display. So there should be a 2, 1, then a 3. A couple people did ask. Let me just show you something real quick from my GitHub thing. I have a file in there called GitHub push that has, I remove the executable, I add all my files, then I do a git commit, just say updated, and then it pushes to origin master. It does all your GitHub stuff. And so what you do is you just create a file that looks like that. And then out here, if you type ls, you see how, oh, sorry. You see how this guy's in green? if I do an ls dash, is it ls dash l? This shows me kind of a long version of all these things. These are the permissions, read, write, and execute permissions for each of these files. So this is read, write, execute for the owner. This is read, write, execute for the group that the owner belongs to. This is read, write, execute for the for everybody else. So this last three is for everyone else. So the default for all our files are just read and write for the owner in the group, and then read only for people that are outside of our, like if you logged into my machine with your user account, you wouldn't be able to change my file, but you could read it. But if you need to change the mode on a file, you would do chmod, and then you give it a, it's a 3-bit decimal value for read, write, execute. So I'm going to say I want it to be read, write, and execute for me. Read and write for, read and execute for the group. Read and execute for everybody else, something like that. That's probably a common mode for this. So read, write. But if I change this guy to like 555 on GitHub push, and then I do, that still does read and execute. So let me do 700, for example. See this guy, he has no permissions other than the owner of the file now. So typically you'd make it 755, and that'll make it read and execute for everybody and read, write, execute for me. And now this guy will show up in green, which means that I can do a git/GitHub push, and it will run through here, ask me for my GitHub username and password, and actually upload it to GitHub for me. So I wrote the series of commands that I would issue by default, that I would type in manually, and I put them into this file. So that whenever I need to do it, I can just call this file. Does that make sense? So it just automates that task of me doing those things. Go ahead.
Does that, when it runs, does it run all of that as like one stream of like one command? Or does
One
it
command at a time, just like you typed it. So it does this, presses enter. Does this, presses enter.
Okay.
Does this, presses enter.
Okay.
Yep.
Does it need to have the blank space after 4? Like, does it need that? Or do you have to like click enter after that? Or does it automatically do that?
Well, like
After the last line, do you have to click?
Oh, no, I think it doesn't care, yeah.
Okay.
So just a way of when you have to repeat commands over and over again for you to automate it real quick. Just create a file with those commands in it. Nothing special, you don't have to compile it, just create the file and then make it executable. So do that line on it. We're changing the mode of the file to 755, then the name of your file, and then it'll show up in green.
Make a file.
Well, that makes it read, write, and executable by you, read and executable by everybody else. Don't worry about that for right now. If you want to go learn about ChangeMa, go look it up. It has nothing to do with this class. I'm just giving you a quick automation.
So basically just type CMod 755.
chmod 755 on the file, and it'll make it executable. That way you can run it, and it'll do your, Or don't do that and just type it in manually. I'm just giving you a quick shortcut. Some people had asked me about it. Yeah.
When I typed git commit, it didn't work, but then I did git commit -a, like what you had, -m updated, how come, what's the difference?
Because commit requires you to give it a message associated with the commit. You can't just say git commit. It says you have to give it a label like, oh, I've updated something. Yeah, so I'm just always, my nondescript message for every one of my updates is going to be updated.
So what's the -m?
Dash message, yep. This is a command line argument. So the git command takes a command line argument. I'm giving it the command line argument of commit, -m and the string. Those are the command line arguments associated with the get command. Somebody wrote this program and requires three command line. Actually, it'll accept more than three, but it requires, so if you say commit as your first one, it requires at least two more, a message and a -m and a message.
What's the dash U?
Upload. I think it's upload. All right, so we'll go ahead and test this. So, I mean, similarly, if you want to do something for your build, you can do, a similar type thing. But, we're going to do, G++, star.cpp. And that then gives us an a.out. I'll go ahead and run this, and there's our list 213. 3 being the new end of our list that we just added. That make sense? Go ahead.
Really quick question. Okay, so back to cmod. So you simply type in cmod 755 GitHub push, and then that will put it in, and then
That makes the file executable so you can run it.
So then after that command, you press .github push
//
//
That says look in the current directory,
Yeah.
then run that command.
You don't have to do the ls del.
ls just shows you what's there.
Yeah, that's why.
Yeah, make sure you're practicing these command line things so you understand what they do. This isn't a memorization thing. This is just almost a muscle memory type thing.
I just wanted to make sure. I get confused with stuff if you check something.
But these aren't requirements. I mean, you can just type the stuff in manually and move on with life. All right, so there's our addEnd. Now we want to getEnd. So I'll steal this getEnd thing. We'll go into LinkedLists CPP. We'll go ahead and write getEnd, which is actually going to have a lot in common with our other one. This is going to return the int @end. Just like last time, we're going to assume that you're only calling this if there's at least one thing in the list for right now. So we'll have a node pointer cur node, and we'll start this off at this .head. Then while cur node get next node is a thing. Cur node is equal to cur node dot get his own next node. So once we're here, cur node points to the end of the list, and we'll go ahead and return cur node dot get payload. We're not removing it, we're just giving the value that lives at the end of the list. Go ahead.
For all these end methods, would it be smart to put that loop in its own thing, go to the end?
You could write a method that says, run to the end and give me a pointer that does that. Yeah, that's not a bad idea. Yeah.
Or do if you have nothing in the list and you call this?
Well, if you have nothing in the list and they call this method, then this is going to give you a segmentation fault as of right now. So that's why I said we're going to assume that we'll only use this tool if we have something on our list for now. Because we're going to deal with exception handling later. I don't want to muddy the waters right now.
Wait, so you literally just retype the same code, or have the same code that we basically.
That's what he was saying is we can come in here and we can create a private method, maybe called node pointer run to end of list, something like that. And then come in here to our linked list, and I'll write it before this guy.
Does it matter if you had to write it before?
No, I'm just keeping it in order.
Yeah, I see.
So we'll create a node pointer. Actually, here, I'll just steal this code. and then we return kernode. That's what run to the end of the list does. So then what we can do here is we can run to the end of the list. What we can do here is run to the end of the list. And notice that I put this guy in the private section. We don't necessarily want this accessible outside of our linked list class. We want it to be something that you can only use as a tool within there. So whenever I need to run to the end of the list, I'll go ahead and run to the end of the list. And I'm doing that in two separate places here. So here, let's just test it with our current code. So there's our 213 still. And then if I want to, where's my driver? If I want to go ahead and say int a is equal to ll getEnd, that will get me the payload that lives at the end of the list. Then I can do standard cout a. I think that's a thing. Let me just show you. Endl's not a thing? Or is that a standard lib thing? Where does endl live? There it is. This is equivalent to \n. Endl does a.
Why is there a red line? Why is there
Maybe it needs to be standard lib.h.
That's still squiggly. Oh, down.
But does endl not live in there? Endl lives somewhere. It's a thing. You might see it in Google somewhere. For right now, just do your \n thing.
Yeah, I think that's much easier.
Well, I'm just saying if you look up code online, I think it lives in standard library, but it's like the iostream. It's wrapped inside of something called standard that's inside of iostream. So that's why we're having to write it like this. We can probably do a /std up here or something like that. But whatever. This will kick it down a line. So now we're just going to test our last thing. So we should get a 3 printed out twice because it's going to print the list, and then it's going to show us that we're able to get the end of that list. We didn't remove it though, because if I print that list again right now, if I display that list a second time, we should still see the 3 at the end of it. So there's our 213. There's our getEnd, and then the list still has 213 in it. We did not remove it. We just got the last value. Make sense?
But then when we ran it, so basically it's going through it twice.
Yeah, I called it twice.
Yeah, the display method, but because you added the end just once, it doesn't add the end again when you go through it again.
Because it goes in order. I build my list here.
Right.
I display it. I just prove I can get the end of the
Okay.
list.
It's like,
Then I
okay.
display it again.
So if you were to put in that method again with the getEnd, it would put another 3 there. Okay, I see.
Yeah. Yeah.
Quick
I
question,
see.
just because I'm curious now. Would iostream and iostream.h be any different? Because the method you were looking at, the endl, is
Yeah.
supposed to be iostream, which is just weird. I'm just wondering why. Yeah, I don't know.
Yeah.
Weird. Okay,
It's
I was
probably
just
something
curious.
with the newer version of the includes
Sure. Okay.
that I'm not familiar with. I'm sure with a couple minutes with Google, we could
Yeah.
figure it out.
Okay, I was just curious.
But yeah, it definitely used to be a thing.
Sure. iostream.h and iostream should be the same thing, or there might be
In theory, but it looks
Okay.
like that they, my guess is iostream is now something called a namespace,
Oh,
which
okay.
is newer. a much newer thing. So it would be it came post C#. So
Okay.
that's my guess is they now have it in some sub package inside of that namespace.
Okay.
Okay,
Isn't that usually done to avoid issues?
it's an organizational tool similar to packages in Java.
Yeah.
It allows you to kind of organize your code, and when you're working on a really large project, and you go and you figure out how the organization thing works real quick, and then you use it from that point forward. But for us, we're doing stuff pretty small here. Really, it's probably more than one, more than 20 classes,
Basically.
like a whole bunch of classes, not so much not lines of code.
Yeah.
All right, so that is our getEnd. Now for removeEnd, we want to think about how this will work. For removeEnd, me getting to the end thing, that's the guy I'm ultimately going to remove, right? But then I need to then get to the guy that's right before him, right? Okay, now we do already have a remove front, correct? So let's start with that. So what I can do is for removeEnd, I just want to make sure I spell it right here. For removeEnd, I can go ahead and I can use count in this case, or I could ask the question, if not this head get next node. What that says is if head's next node points nowhere. Here, I'll put it beforehand. This basically asks the question, is this a list with a single element in it? That's the question that's asking. Again, we won't call removeEnd unless we have one element in our list. All right. So this asks the question, if head's next node points nowhere, that means we have a one list. And if we have a one list, we can go ahead and just return this dot remove front. We already wrote that logic. Make sense? Else, we have at least one element. Let's see, at least two elements in our list, which would allow us to get to the last guy and the guy right before the last guy. All right, so we already know how to get to the last guy in our list. So I could say node pointer, the last guy, is equal to this dot run to end of list. Now the last guy will point at the last guy in my list. Make sense? All right, now I want to get to the guy that comes right before the last guy. So I'll say node pointer, the guy before the last guy. We'll start this guy off at this dot head. And then we're going to run him to the point where he points to the last guy. So while not the guy before the last guy get next node, actually, look, we're going to write it this way. While that guy is not equal to the last guy. Okay, so the guy before the last guy, get this next node, while he does not equal the last guy, we want to go ahead and advance him down our list. So the guy before the last guy is equal to the guy before the last guy, get next node. Okay, so when we get here, the guy before the last guy now points to the node right before the last guy. So if I draw my picture here, this is the last guy. This is the guy before the last guy. So our picture would look like that.
Which they're two separate entities, or they're both the same entity?
Well, this guy points to one entity, this guy points to a different entity.
Oh, I'm looking at the.
Go ahead.
I didn't, sorry.
I have a question on, for the if statement you have in the beginning of that.
Mhm.
Wouldn't that only run if there currently isn't a node, and then it wouldn't be able to return an int because the remove above that. Sorry, so it's basically saying like if there isn't currently a head pointer node.
Well, no. This says if head's next node. Actually, I'm missing parentheses there, but so this guy is presumed to exist in here.
Okay.
We're assuming it's at least a one list.
Okay.
So what we're really asking here is if that guy does not have a
Okay,
next node.
Okay, sorry, that makes sense.
Here, I'll put a little note here. We are assuming the list has at least one element in it for now. So we're really asking, is it a single element list or is it at least a 2-element list here?
Okay.
If it's a single element list, we'll just call our remove front because that does the same thing as remove end for a list with one thing in it. Otherwise, if it's a list with at least 2 things in it, we're going to have to do minor surgery. All right, so I get 2 pointers, one pointer to the very last guy on the list, another pointer to the guy right before that guy. So when that's said and done, even though in this case I have my 2 list, but we'll have the very last guy and then we'll have the dude right before him. What do I want to do? I want to take the dude right before him and I want to disconnect his next node. All right. So now we're going to have to go ahead and get our null value. Well, it should be, well, I'll just hard code it. It'll be fine. So we'll say the guy before the last guy, set next node, equal to 0. Go ahead.
Couldn't we just remove the last node and then call run to the end of the list again and set that equal to the last guy? Does that make sense?
So you want to call, well, we're in the middle of writing removeEnd.
Okay. Could you, I guess, delete the last node and then?
Oh, so actually that's not a horrible idea.
Okay.
So,
Wasn't sure if you.
yeah, it's a little bit dangerous. So what she's suggesting, what I think you're suggesting is this. Run to the last guy, grab his value. So we have, in this case, the 9. So we have something to return. Then delete this memory. You can do that. What you'd end up with, though, is this guy pointing to an actual memory address. You wouldn't be able to say, does this guy point nowhere? Because he currently does point to a memory address that happens to not have a node there because I've deleted the node. So what you would have done is you would have erased this guy from existence, but if the operating system were to hand this to something else, you now have a node that points to, it could be something from like, a word processor or something like that. So probably would not be a problem. Probably would not be a problem, but it's a sort of kind of like, I don't know, kicking something under your bed when you're trying to, faking cleaning up your room, something like that. We're not being very thorough.
So she's saying like go to the end of the list, grab the value, and then go to list of when you just delete the address on the last node.
That's what I'm saying, is if we delete this address, which is fine, now the actual node is gone. But this guy's next node, which holds an address, will still hold that memory address.
What can you do?
We're deleting it anyways. Yeah, we're going to delete it. But if we don't delete that memory address, we now have it pointing. So if somebody demolishes my house, and you have a Post-it note that has my address on it, and then somebody else comes and builds a new house on the plot of land that's my house, you can now go to that new house and spray paint the garage, right? You're messing with somebody else's house. That maybe they build a gas station there. It's not even a house, right? You can go to the gas station and do something that maybe you weren't supposed to have access to, but you still have access to it because you have an address where it lives. So we do need to make sure that we do disconnect this guy. We do want to delete this memory.
Would you delete the address on the last one, or the new last one now?
Well, why would you want to? I mean, you want this guy to still exist, don't you?
Yeah, like the address, the next node on that one. The address.
That's what we're doing.
Okay.
That's what we did right here. The guy before the last guy set his next node to nothing. Yeah, that's deleting that address. He no longer points there. It's doing this disconnect right here. So I currently have pointers, so I don't lose track of the two guys. I have a pointer pointing to the guy before the last guy. I have a pointer pointing to the last guy. So now I can safely say the guy before the last guy set next node to 0. Point it nowhere. I can disconnect it. Then I can say int value to return is equal to the last guy get payload. That'll get me the number from that. That's because this guy's going to return an int. That's going to extract the number from that I want to return. Then I can say delete the last guy, which will eradicate this. Give back that memory.
Why do you need to get the payload if you just delete it?
Well, because I've advertised that my method here is going to return an int. It's going to remove the last node and return its value. So I definitely don't want to delete it and then go and try to get a value from something that no longer exists. So I'll go ahead and grab his payload, copy of his payload, his int. It's like, okay, I'm going to hold it here and then blow up the memory, but I still have the value. So now I can toss it out and return value to return. That make sense? So that's removeEnd. So the difference here would be when we go to our, where's my driver? Right now, I'm adding my list, so I have my 2, 1, 3 is my order of my list. Then I'm displaying my list, 2, 1, 3. Then I'm saying getEnd. We're going to update this to removeEnd, which should still get us that value, the 3. But now it's actually deleting that node from the end of the list. So now when we go through and display our list again, we should only see 2, 1. Because our list has actually shrunk. We did forget one thing here. We did just remove something from our list, so we need to decrement our count. All right, so there's our 2, 1, 3. Then we removed the last element, there's our 3. Then we displayed our list again, there's our 2, 1. Make sense? And how we did the surgery. And also we cleaned up our mess. That's what we're doing right here.
So in main or driver, are you telling it to print? It print, okay.
Yeah, this prints the int of the last node that we just deleted. because I'm removing end now instead of getting end. Good.
If you create like an infinite loop and you try and get out of it in your terminal,
Control C.
thank you.
Yeah. If you're sitting out at the terminal and you've entered something and it's not stopping, hit Control C. That'll kill it. All right. So that's the homework for today, right? So I'll go ahead and upload that. So that's GitHub push. All right, so now that's up on GitHub. See the convenience of that. So one of the reasons that we're having you use Linux now, first of all, was by this point we should all be real computer scientists, right? And not Windows and Mac users, which is fine. There's nothing wrong with those, but we starting to see the power of something like this. Because now you can use your pseudo programming skills, let's say. I mean, this wasn't really programming to write this little script. But we said, hey, I know I need to issue these 4 commands. I'll throw them in a script and just run those 4 commands whenever I need them. Go ahead.
When you're doing GitHub from the terminal like that, how does it know it's going to that specific repository?
Because you would have had to do your original setup. So if you want to cheat, let me just open this up. So if I go to, we'll just do a quick one, github.com, and I go and create a new repository like this, and let's just call this guy test 2, whatever. All right, I'll delete it here in a second. When I say create repository, it's going to give me those instructions that I should do initially. This will initialize my Git repository in that directory. I usually don't do that line. Then I would do this, the git remote add, and then from that point forward, I can say git commit and git push.
So whenever you're running those,
It's only happening in that directory using the repository that was generated for just that directory.
so if you were to go to another folder and do the git, it would be totally different.
Yeah, it uses the local .git folder that gets created when you do a git init. You do git init exactly one time. You do git remote add exactly one time. This is what tells that local guy to commit to this particular repository. So those 2 things happen exactly one time in that directory. And then from that point forward, you can add all the files, commit the files, push the files. Go ahead. No, I usually don't. I just upload your current version of your branch. Yeah.
So can you have one folder connected to 2 repositories?
No.
Okay. So there would be no reason to, in the terminal, have to switch between repositories because you just switch to different folders.
Correct. Yeah. But you could have a top level folder have a repository, and then that guy have 2 subfolders in it, each of them having a repository. And then those repositories would get stored. So that's, I don't know if that's what you'd want, but that's possible. But an individual directory can only have 1 repository from .git.
Could we have uploaded to GitHub through the Mac Unix terminal last semester?
Oh yeah. Same exact way.
Yeah.
But I figured you probably sucked too much to do that.
Yeah, we weren't orange belts, yeah.
Yeah. And Mr. Gonzalez and I yesterday, we were practicing breaking boards in the living room. Yeah, so I broke a couple boards, and I left this like about 6-inch thick sheet of steel next to him. Came back, it was shattered. Not just in half, it was in pieces. I don't know how that happened. I'm thinking that's open palm, maybe. What's that?
Punching with his foot.
Mm. He is punching with his foot. He died from a punch, I'm sure of it. But the bruising patterns was that of a foot. I know it makes no sense. All right, we have to watch that sometime very soon. I keep saying it. We just need to set it up and do it. Yeah.
I'm so down for that.
You can rent out a
Organize an
theater.
event. I can
It's
make
actually
it like
super cheap to rent out
one of my RA events. Like you can
Yeah,
come
it's like-
watch a movie. Be
like 150
if you want to
bucks.
learn how to become a master.
we need to do it.
Yeah, that'd be just-
Let's do this.
collaborate. I'll do
All right,
it.
shut up.
We should rent out a theater.
So what?
Rent out a theater.
Rent a theater?
It's super cheap. Theater.
Yeah, but I think there would be some because we're streaming it off Hulu. There's some.
No, you can like rent a theater and they can play whatever movie you want. Like at Marcus.
I understand, but I bet you there's some legal reasons why you can't like stream a Hulu movie to like a crowd of 40 students in a public thing. I mean, if we're doing it in a large dorm room, like across the hall or something like that, that's kind of like you and your buddies coming over and watching a movie, not the end of the world. But if you're showing it in like some sort of public venue, I think there's some laws associated with it, huh?
I think they can play little movies though. Like if you tell them that you want to like play a movie that you see.
It's possible.
They might still have access to it.
Let's
And then you get free
Switch
popcorn.
to the projector.
Yeah, we did.
Yeah. So I'm just saying there might be some legal ramifications to that. We do have an 82-inch TV over there, so it's not like we have a major issue. We could just scoot in 109 the TV to the front of the room and watch it, and then we effectively have our own theater without like legit oversight. Huh? That's right. We could collect an entrance fee.
You can send like
$75 to watch this. Like, that's like a year of Hulu subscription. It's $75, white belt. All right.
part of initiation.
That's right. We're at this point, we're like borderline hazing.
You already passed that way.
Yeah, everyone had to do it. Trust us. It's all part of it. It's part of the requirements to graduate.
How'd you break your hand?
You guys have it easy. You should have seen what we had to do.
Yeah.
You get extra credit to figure out how to weigh their legs.
We're just like making this collection as we go along.
Our joints only bend in one direction. It's what gives them strength. That's right. Clancy, come up here. I want to give a demonstration. That happens in the movie. So good. All right. So now the next thing we might want to do is add, remove, and get something from the middle. Right? Okay. Yeah, get an index. That would make some sense. So the next thing, so let's add it to our header file here. So we're going to add at index, int index, int payload. We will get index, int index. We will get remove index, int index. All right, so these will be your next three methods for Tuesday. Now let's talk about these for a few minutes. For starters, and actually I'll give us a starting point here for, well, actually I won't. You should be able to figure that out. But we'll talk about it at the high level. So if I want to add at index 0, what am I actually doing? Go ahead. Adding to the front. Okay. If I want to add at index count, what am I doing? Adding to the end. All right. So when we say add at index, we want to make whatever we're adding become that new index. All right. So right now, if I think about this as an array, this is index 0, this is index 1. So if I want to add something at index 1, I'm inserting it between these two. So it becomes the new index 1, displacing the stuff after it to become, this guy would become index 2. All right, so let's look at how that might look in this case. So I'll scooch this guy over to give myself a little space. And I'll scooch this guy over. I've really made pretty large nodes here. It's kind of inconvenient, but in an awesome way, I guess. Well, from a picture drawing perspective.
Yeah, it just looks kind of, it's like all these lines are going everywhere, every which way.
Well, those are the important part. The lines are the important part. I'm talking about the size of my nodes here.
Yeah, they're big and large.
Okay, so if I'm going to create a new node like that, and I want to add it, and my current list looks like this up here. And I want to add this guy at position 1. This is currently bucket 0. This is currently bucket 1. I want this guy to become the new bucket 1, which would then make this guy become the new bucket 2. Okay? So we need to figure out, how do I do that? Well, I would need to do, here we're going to, I would need to run through my list and get to the node that comes right before where my new guy should be. Right? So if I'm adding it to bucket 1, in this case, I need to get up to bucket 0. If I'm adding it to bucket 5, I need to get to bucket 4. That make sense? So I need to position a pointer right before where my new guy should go. Now we might be tempted, so you need to get there somehow, whatever that means, okay? You might be tempted to say, oh, well, so this guy's next pointer goes here. Well, what did I just do? I lost this guy. Bad news bears. This is why you should draw pictures. Okay, so I can't do that yet. So instead, what do I want to do? I want to set end's next node to point to this guy. Then I can safely take this guy and point it here. And now I've inserted that at bucket 1. Make sense? Or bucket 2, or bucket 3, or bucket 4. Anything but bucket 0 and bucket last. All right. Now, what if I were to get the value at bucket 1? That one just says run to bucket 1 and return the int that's there. Not too bad, right? But now the third one, a little bit more difficult. We need to, we're removing the foreign body from our list here. If I want to remove from index, for example, bucket 1, because that's what I have displayed here. If I want to remove this guy, I'm ultimately going to return his payload, but I need to disconnect him from my list. So how do I do that? Well, I need to get to the guy right before him. Then, now I can't just do this, right? I can't say that. This guy is already created, so end no longer points to him. So I can't make next node from the guy right before just point to to the next guy's next node. Because now I've lost track of this guy, and he's the one whose value I want to return, and that's the node that I want to delete. So instead, what do I have to do? I'm going to have to give myself a pointer that will point at the guy I'm going to remove. That is the guy before his next node. Then I can set the guy before his next node to be the guy to remove's next node. So they both point to the same place. Then I could set guy to remove's next node equal to 0. Then I can remember the payload that we're going to return, and then I can delete this memory. Make sense? So that's the surgery we will be performing for our next assignment. So 3 methods. addEnd index, So that puts something somewhere in the middle of the list, treating bucket 0 as an add front and bucket count as an add end, if I want to add something to the end of the list. We can assume that they're not going to say add at index 4000 when you have a 3 list. Although if you want, you could just assume if it's greater than or equal to count, you want to add it to the end. But you could assume whoever's testing your code is going to use it reasonably. I'm not saying that in industry you shouldn't do a lot of error checking, but right now we want to focus on our mechanics, not every little stupid thing that might go wrong. Go ahead.
Can you walk through a linked list by buckets, like bucket 0, bucket 1, will it still?
You can if you write it. We're writing getIndex here. So getIndex is going to allow us to treat it as bucket 0, bucket 1, bucket 2, but they don't have bucket 0, bucket 1, bucket 2 by default. That's what contiguous memory gave us, right? So we're effectively inventing that. We're saying, you know what? We're used to arrays. Arrays are from bucket 0 to its length minus 1. Let's treat our linked list similarly, but we have to write those abilities. It's not built into it.
Yeah.
So that's effectively what we're doing for this assignment. All right, so that makes sense? So we just drew the picture of what you need to do for the homework. But draw your own pictures. If you're not already drawing pictures, you should do that. Homework will be way easier if you draw pictures, especially with pointers. Because we're starting to see here, there's a lot of lines.
Is it necessary to change the next node of the one that we're deleting? We're just going to delete it anyway.
Probably not, but I would say good housekeeping says you should. So it's a reasonable question. He's asking, do I actually have to set this guy to 0? Officially, no, but I always do. Yeah. It's one extra line of code. Nobody's impressed if you have a little bit less code. Plus, it reinforces in your mind what you're actually doing. We are fully disconnecting, right? If you're performing surgery on something, you don't want to leave something connected to the body. We can get kind of graphic with this, but it would be bad.
You can't just leave the paper.
Yeah, somebody leaves the hospital with a souvenir, right? All right. Any other questions, comments, concerns, bribes?
No.
All right. I will see everybody on Tuesday.